All right. A geometric series is the expression for the sum of a term of a geometric sequence. So what you did for bell work was geometric sequence. You found the explicit formula for the sequence, and then you found the first three terms in the sequence. And so now a series just adds those up. There is a sum of a finite geometric series formula here. Finite meaning, we talked about this yesterday, there is an end to it. Infinite means it goes on and on with a little dot, 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 which is called an ellipsis. Ellipsis. So the sum of a finite geometric series is displayed like this. A sub 1 times 1 minus r to the n over 1 minus r. I suggest you just memorize the formulas personally. To point out, a sub 1 is the first term. R is your common ratio. That's what you're multiplying by to get from one to the next. N is the number of terms that you have that you are adding up. And then R down here again is your common ratio. So you literally just plug it in. Let's look at how we use it. Use the formula, it says, to evaluate the series, and they give us this series of numbers. Obviously, you can add them up, but they specifically said use the formula, all right? So the first thing we need to figure out, because in order to use this formula, we need our first term and our R and our N. So how am I getting from 3 to 6 and 6 to 12 and 12 to 24 and so on and so forth? How am I getting there? I'm multiplying by what?
2.
So times 2, right? I'm multiplying by 2. So my common ratio here is 2. The other thing that I need is the first term. A sub 1. First term, they just handed it to me right there. My first term is 3. And then the last thing I need is the number of terms. How many terms do I have?
6.
Right, I have 6 terms. So my n here is 6. And so if I were to plug this in, I'm just going to use the formula that they gave me. I would say the summation of that is going to be the first term, 3, 1 minus my common ratio, 2, to the n, which is 6, all over 1 minus 2. And then you just do it, all right? So if I were to plug this into my calculator, 2 to the 6th is going to give me 64, right? 1 minus 64 is negative 63. So I have 3 times negative 63 over negative 1. 3 times negative 63 is negative 189 over negative 1, which means my sum is 189. So you're literally just plugging it into that formula and solving. In March, the Floyd family starts saving for vacation. In August, the Floyds expect the vacation to cost $1,375. They start with $125 each month. They plan to deposit 20% more than the previous month. Will they have enough money for their trip? All right. So, first of all, 20% more than, you don't want to use 0.2. 0.2 will actually not help you here. It's going to be 1.2. Okay. Why is it 1.2? Because it's 20% more than is what you're going to be multiplying by. And so your common ratio is going to be the amount you already had times 0.2 and added together. So it's times 1.2. The amount you already had times the 0.2 and then added together. So 20% more, you would use 1.2 here. And that's actually one of the questions they ask you, but that's what they're doing here. All right, so we are going to start with our initial amount. What is the initial amount here? So a sub 1 in this particular one, is 1375. The common ratio, what you're multiplying by, is going to be 1.2. Now, here's what I want you to realize is you're talking about a series here, 1375. If I just multiplied by 0.2, my next number would not go up, would it? No, it would go down, right? And so this is where the 1 comes into play. It's actually, I would have the initial amount plus the 20%. And so this is where my R comes from. How many terms do I have? How long do they have to save if they go from March to August?
Like, do they deposit in August?
So our N here, our N would be 6. So we would say N equals 6. And so if we have all of that, we're just going to plug it in. S of N equals my first term times 1 minus my R to my N all over 1 minus my R, right? And if you plug all of this in, yes, you would use a calculator for 1.2 to the 6th for sure. You would get 1241.24. How much did their vacation cost? $13.75. No, that would not be enough. So they need to deposit more. Right? Yeah. No, your initial amount is not that. They would definitely have enough if they started with that, wouldn't they? That's going to make more sense.
They start with how much they need.
So, then they're going to definitely have enough. Yeah, you would start with 125. Let's talk through B. Suppose they deposit 25%. What would change?
They'd probably.
What in your formula would change specifically?
The 1.2.
The R would change to 1.25. So then calculate what their savings would be at the end of 6 months. In some cases, you can evaluate an infinite geometric series. Infinite meaning it goes on forever. When the absolute value of your common ratio is less than 1, the series converges or gets closer and closer to the sum. When the common ratio is bigger than 1, the series diverges or approaches no limit. So converges means your R is less than 1, the absolute value, and you can calculate the sum. If the R is bigger than 1, it diverges and it has no limit. It goes on to infinity, all right? And so this is just trying to decide, does it converge or does it diverge? So you just want to figure out what your common ratio is. So for this first one, what is my common ratio? It is negative 1/3. Is the absolute value of negative 1/3 greater than or less than 1?
Less than.
It's less than 1, which means this one converges. All right. What about this one? What's my common ratio for this? 2. This is my geometric series, right? Is the absolute value of 2 greater than or less than 1? Greater than. So this one diverges. You cannot, it will have no limit on this one. This one you can calculate, this one you cannot. All right? What about this? A down here. What is the common ratio? 1/5. Does it converge or diverge? Converge. What about this one? Common ratio is? Converge or diverge? Diverge. All right, sum of the infinite geometric series. If an infinite geometric series has a common ratio absolute value of less than 1, which means it converges. So if you have determined that it converges, then you can use this formula. If it diverges, you would say, no, I can't use it. There's no limit. Then it's just the first term over r minus 1. Very simple formula. The first term over r minus 1. All right, so we're going to use that formula with something y'all have probably seen before. The length of the outside shell of the closed chamber of a nautilus is 0.9 times the length of the larger chamber next to it. Estimate the total length of the outside shell for the enclosed chambers. They've given us the term 27. That's my starting one, and we're going in from there. 27. My common ratio is the 0.9. They told me it is 0.9 times the length. So my initial starting value is going to be 27. My R is going to be 0.9. And I'm just going to plug that in. Starting term, 27, divided by 1 minus 0.9. That ends up being 27 divided by 1/10. So times 10, you would get 270.